Causal dimension. If we look at the different types of dimensions that exist, then there's one that stands out, and that is the causal dimension. What is that, you may ask? Okay, if you look at the design of your star schema, you can see that there's been a sale. For example, by writing in the fact table that a sale has taken place by adding an order line there. You can then associate it with a customer, and you will then know that the sale was for that particular customer. But what may be much more interesting is the reason why that sale took place. And that's what a causal dimension does. This explains why the line exists in the fact table. For example, you can add promotions or coupon information. You thus create a dimension that describes why something happened. Adding a causal dimension is not complicated, because adding a table to the model and an additional field in the fact table is not that difficult. If you do that, you'll have a lot of really useful information. And what's nice about it is that you can also reverse this. For example, if you find that something has been sold during a national holiday, then you can also see that your sales during these days are different than on regular sales days. It is therefore good to also register as facts things that may not be so obvious at first. If we register a promotion, we know that our sales were higher because we had a very good promotion. And conversely, you can say, for example, compared to the previous month, when there was no promotion, nothing happened. And so, the Y dimension, as the causal dimension is also known, answers the question. Monster dimension. Another type of dimension is the monster dimension. The monster dimension is one of the easiest dimensions. A monster dimension is simply a very large dimension. If we look at the fact table, it may contain millions of records at any given moment. After all, you are tracking all sorts of sales or other relevant information. A dimension can also grow very fast. Imagine that a supermarket chain offers a store card to its customers, and that every customer has such a card. With each sale, new customers may also be added. The customer dimension thus grows almost as fast as the fact table, creating a huge dimension table. If you have a dimension table that contains huge amounts of data, this is called a monster dimension. Mini dimension. The following dimension is called the mini dimension. No, it's not the opposite of a monster dimension. So what is it then? It's a dimension to save attributes that change very quickly within the dimension. What do we mean by that? Let's look at a fast-changing dimension. In this case, it's our customer dimension. Why is it changing so rapidly? If you look at the customer key in the first column, you will see 1001, 1002, 1003, and that the customer number is in a separate field. We have learned that this is a slowly changing dimension type 2. So what's happening? Here, we see an income and a status, and those are constantly changing for some reason. The changes are occurring so rapidly that many lines are continually being added. The problem is that the income and status are being logged in the customer dimension table, but the customer has many more fields than just income and status, which also includes attributes. He has a first name, surname, address, and much more. There is also, for example, a zip code or residential address. There may be 30 other attributes that are also included in this dimension. In practice, this means that each time the status or income changes, a new line is added. All other attributes are then copied just because there has been an income change. In the long run, this can take up a lot of unnecessary space, especially if we have millions of customers. Okay, so what do? We create a new type of dimension. In this case, it's a mini dimension. We split off those rapidly changing fields into a new table. This then becomes a new physical table in the database. We call this the customer profile dimension, for example. Here we have a profile ID with attributes related to income and status. So now they're out of our customer dimension, which means our customer dimension will now change less rapidly. How does this impact on your fact table? If you look at your fact table, a new field has been added, in this case a customer profile ID. This means that every time the customer profile changes, a row is also added in the fact table. Heterogeneous dimension. And then we have yet another dimension, the heterogeneous dimension. Let's first take a look at the definition. A heterogeneous dimension is a subtype of a dimension in a separate table. Let's deal with our product dimension because we sell products online. In the first two columns, we do not see anything unusual. The first column is the product ID. This refers to our fact table. The second column shows the name of our product. But our company sells various types of products, including computers and printers. Perhaps we'd like to know how many computers are sold with 2 GB of internal memory, or how many printers are being sold that can print 30 pages per minute. As you can see, you can extract various types of reports from this table. That's all very well and useful, but this table also has a problem. Because, in our example above, the computer cannot print X amount of pages per minute, so this field is left blank. In database terminology, this is a null value, NULL. In general, the rule is that it's not good to have null values and you should avoid them. Okay, so how do we solve that? Well, it's actually quite simple. Subtypes are created. We have our product dimension table and this is made smaller. In this example, it has only 2 fields, the product ID and the product name. These 2 fields will always be filled and thus do not generate null values. The other fields no longer exist in this dimension. Next, there is another table that is called, for example, dim computer properties. This contains a product ID field, which is the same product ID as the one in the product dimension table. Furthermore, it also contains the specific features of a computer, such as processor and memory. In addition to this table, there's another table, which is called dim printer properties. This table also contains, firstly, the product ID field, which has the same product ID as the product dimension table. In addition, this table contains the specific characteristics of a printer, such as the number of pages it prints per minute, color, and number of drawers. Now you can see that there are in actual fact 3 tables that describe the product. All 3 refer the product ID to the fact table. So if you want to display specific details about a printer for your report, it's therefore important that you use the fields in the printer property dimension. Other dimensions. We have now discussed the most commonly used dimensions. There are more dimensions that occur less frequently. There's the audit dimension, for example. These contain rules that say something about your data. In addition, there are other dimension tables, such as the degenerate dimension, the junk dimension, and the conforming dimension. It's good for you to know that these exist. However, we won't discuss them here because they do not occur very often. If you do encounter any of these, it would be wise to ask your technical department for an explanation.